Welcome to this video, which is part of a series on an introduction to functional programming using Scheme. The presentations were created by Professor Mark Kovatsa at the University of Greenwich, and there is extra material provided by Dr. Yasmin Arafa, Professor Cornelia Boldareff and Dr. Ralph Bartel. My name's Andy Wicks, and any errors in this video are mine and all mine. So let's get going. Welcome to this video on recursion, the functional programming way in Python. In this video we're going to look at recursion, and we're going to use a mathematical tool called the Newton-Raphson method. We are not interested in the maths. The maths is merely there to illustrate the recursion. In this technique, what you do is you make an initial guess of a square root, and then it goes round and round a loop until it finds the square root to the precision that you want. In this case, we're going to assume that the precision we want is 0.001. In other words, we want it correct to at least 2 decimal places. But you could set that to anything. I'm just doing this for illustration purposes. In the functional programming version, I'm going to set up 2 lambda expressions, each of which take in the number that we want the square root for and whatever the current guess is of that square root. The first expression is a Boolean expression and says whether our guess is so close that we're only 0.001 out or less. The second expression calculates the next guess. So it does a bit of arithmetic to find out what the new guess will be. We're not interested in the arithmetic here, remember. We're just interested in the fact that a new guess is being created. Now we're going to create a function. And you're thinking, this looks very much like standard Python. There's a good reason for that. It is. But it's a top-level function. It only takes input. There are no other extraneous bits that are being used in this function. So we feed in a number and a guess, and nothing else comes in. Except that in this line here, we're checking whether the value returned is true or false. So check will either return, yes, it is less than 0.001, in which case it will print out the guess, or if it's not less than 0.001, it will call exactly the same function again, but this time with a new guess. And so we keep all the work within that Newton-Raphson square root function. So it'll go round and round until it prints out the guess. Now we have to call a function, so this line here calls the function Newton-Raphson square root, and we're looking for the square root of 77, and because I'm old and silly, I'm going to assume that the square root of that is 2. Now we're going to do exactly the same process again, but this time with standard Python. As you can see, what we need are 3 separate functions. The first function takes in a number and a guess and calculates the true or false value of whether this particular bit of arithmetic ends up with something that's less than 0.001. The second function here calculates that new guess, whilst the final function is a standard piece of recursion, as you've probably seen in many other places. We've got a function called Newton, which we're going to use to return either the guess or to call itself again with the number and the guess. And we'll obviously need to work that through with a print function to print out whatever the answer is. So let's see if this works. Well, surprise, surprise, it does, and both methods give exactly the same answer. However, the functional programming version is much shorter and keeps the things that are in one idea all in one place. So you don't have to wade through code. The functional programming version doesn't just result in shorter code, but also code that's easier to read. And the easier your code is to read, the more likely you are to get promoted, because they can put somebody else in your place without having to worry, because your code is good.